Good morning. Today we are going to discuss about Fourier transform. This is the basic formula for Fourier transform and inverse Fourier transform. F of x equal to, denoted by capital F of s is equal to 1 by root 2 pi integral minus infinity to plus infinity f of x e power isx dx. And this is the inverse Fourier transform formula. So here we are integrated with respect to x means in inverse we are integrated with respect to s. These are the hints we are going to use to solve the Fourier transform problem. So e power I theta is equal to, we know, cos theta plus I sin theta. Similarly, e power minus I theta equal to cos theta minus I sin theta. If the function f of x is even, for example, f of x equal to cos sx, if the limit is start from minus to plus, then the function is converted as 2 into integral 0 to a f of x dx. If the function is odd, the limit minus a to plus a f of x dx equal to 0. Now let's go to the problem. This is the first problem. Find the Fourier transform of f of x equal to 1 if modulus x less than a and 0 if modulus x greater than or equal to a. Where a is a positive real number, hence deduce that integral 0 to infinity sin t by pi of t. First we are going to find the Fourier transform, then we are going to deduce, that means find the inverse Fourier transform. So taking the Fourier transform formula. What is the formula for Fourier transform? F of x equal to 1 by root 2 pi integral minus infinity to plus infinity f of x e power isx dx. Now substitute the value of f of x. What is the f of x is given in our problem? 1 of the limit modulus x less than a. Modulus x less than a means what? A less than a minus a less than x less than plus a. So that taking the integral minus a to plus a, in place of f of x replaced by 1. And what is the formula for e power I theta? Already we discussed the formula for e power I theta. In place of theta we substitute sx, means cos sx plus I sin x. So we use the cos sx plus I sin sx into dx. So what is the limit minus a to plus a? The limit is minus a to plus a means the function is even, means we can replace, convert it as 2 into 0 to a cos sx dx. So that 2 into the limit is minus a to plus a. So 1 by root 2 by cos x dx is equal to 2 into 2 by root 2 pi integral 0 to a cos sx dx. So next we are going to integrate cos sx. What is the integration of cos sx? The integration of cos sx is sin sx. We are integrating with respect to x, means divided by s, limit 0 to a. So we can write the 2 by root 2 into root 2. Divided by, what is the denominator? Root 2 pi, they change it as root 2 into root pi. One root term is cancelled. Then the answer is root 2 by pi. Apply the limit if the upper limit is a. So sin s a divided by s. The lower limit is sin s 0 divided by s. What is the value of sin 0? The value of sin 0 is equal to 0. So that the second term turns to 0. The final answer is root 2 by pi sin s a divided by s. This is the answer for Fourier transform. What is the symbol for Fourier transform? F of s. So this is the final answer for Fourier transform. So now I find the Fourier transform formula. Move on to the inverse Fourier transform. So now let's find the inverse Fourier transform. What is the formula for inverse Fourier transform? The inverse Fourier transform formula is started by small f of s. Okay, the Fourier transform started by capital F of s. The inverse Fourier transform, here we are using capital F, means here we are using small f. Okay, so small f of x equal to 1 by root 2 pi integral minus infinity to plus infinity f of s e power isx ds. What is f of s? Fourier transform is denoted by f of x. So we are going to apply the value of Fourier transform of f of x here. What is the value of Fourier transform? Already we find the value of Fourier transform is root 2 by pi sin as by s. So in the inverse Fourier transform, we are going to apply the Fourier transform here. So that 1 equal to 1 by root 2 pi integral minus infinity to plus infinity. This is the value of Fourier transform root 2 pi pi sin as cos sx dx cos sx minus I sin sx dx. That is the value of e power minus ISX is cos sx minus I sin sx. Okay, taking the constant term outside of integration, already that is 1 by root 2 pi. Now we are taking the value of root 2 by pi outside, then integral minus infinity to plus infinity. Here also there is a sine term. Sine term is a odd function. If the function is odd, integral minus in a2 plus a sin x dx is equal to 0, because sine function is an odd function. The odd function value is 0. So this term turns to 0. So 1 by root 2 by pi. So root 2 and root 2 cancel. Root pi into root pi, pi. What about the integral? Integral minus infinity plus infinity is changed as 2 into 0 to infinity, because cos function is an even function. Already we discussed with that. We use the same condition here also. So instead of minus a to plus a, here minus infinity to plus infinity. So you convert by that same formula, 2 into 0 to infinity sin as cos sx dx. Okay, here there is no need to integrate the function, because let's see the question. In our question, they ask the value of the integration. They ask the value of the integration only. Okay, so we are going to prove that value. What is that? 0 to infinity sin t by t equal to pi by 2. So here there is no need to integrate in inverse. So just simplify. So for that, putting x equal to 0 and a equal to 1 and s equal to t. If s equal to t, differentiate both sides, ds equal to dt. Now substitute the value here. So in left side, there is a 1 here and 2 by pi integral 0 to infinity sine. What is the value of a we are taking? A equal to 1 and s equal to t divided by t cos. What is the value of x? X equal to 0, cos 0 into dt, because instead of ds we are changing dt. There is a constant 2 by pi here. So bring it to the next slide. It turns to pi by 2 is equal to integral 0 to infinity sin t by t. What is the value of cos 0? Cos 0 is always 1. So that is equal to dt. So finally, what is the answer for inverse Fourier transform? They ask, we prove that integral 0 to infinity sin t by t dt is equal to pi by 2. That is the final answer for inverse Fourier transform. Thank you.